Good. Okay. So, hello everyone again. As Karen said, this is a paper that we work together as part of the education committee, and I'm happy to speak on all of their behalves. Um, what we wanted to do is basically understand what the current situation in regards to computing and construction education looks like across all of Europe in terms of why or how much are we actually teaching, how many people are we actually impacting every year, and what actually are we delivering. And the idea came basically because, as you understand, BIM is becoming more and more important across Europe in terms of mandated regulations. We need to basically do an extra effort these years in order to digitalize a lot of our workforce because they do not necessarily know and they are very behind in terms of skills and digital skills. And there was no place actually available where we could actually see very easily how many or how much institutional education, institutions were actually providing. So we wanted to do that is to try to understand what the landscape looks like, how many graduates actually are being put through our system as a whole in terms of Europe, and if there's how I would say, try to quantify how far away are we from looking into, creating or closing the gap in terms of digital skills in the workforce. So the idea is I run a very extensive prompt on LLM to capture all of the information as much as possible from all the institutions across Europe. Obviously, that was the first step where we got a lot and a lot of crap as well. Pardon my language. And then we did a manual check by all the person in the committee going university by university, looking into all of the different programs and all of the different institutions that offer programs, checking that they actually delivered something on computing construction. And then the latest point, which came in 2 steps, was actually people from those institutions getting aware of this map of the work that we were doing and contacting us and confirming or changing certain things based on their own knowledge of what they actually are delivering. So we did that. We classified all of the different institutions into different areas based on controlled topic vocabulary. So we didn't want really everyone to be able to say what they wanted to deliver. It was more like we wanted specific topics. And we run a model for understanding whether the impact of the delivery in the workforce is expected or not based on a parametric demand sensitivity. So this is what the map looks like. I think you've seen it. The data that actually I'm showing today is not the data that is actually on the paper. So the paper provided the first version of the data, which was our first iteration that run during the last summer all the way till November. We got so much feedback that we went from 184 institutions and about 300 something programs during the first iteration to what I'm showing today, which is about 309 universities or institutions and about 780 programs across Europe, which means that the first analysis that I did was a little bit far off from the reality. So today I'm showing you more data. So this is what I'm saying is 300 institutions or 301. There's about 39 countries, so pretty much every single country in Europe, about 862 programs, which in total we put through almost 19,000 graduates a year. And that means across all of the different topics that encompass construction education, computing in construction education. And for each one of those institutions, we have all of that information that is there. So we consider not just the name of the institution, the location, the level, but also the language of instruction, the type of study, the delivery, the tuition fee, the number of graduates per program, the topics, obviously, if it's accredited or not, and which accreditation actually is following, and obviously what I talked about before, the level of verification. And then we run an analysis of this big data set that we captured. In terms of distribution, there's 2 things in this graph. The first one is we grouped pretty much all of the countries into areas that we could basically put together. So DACH, for example, means Deutschland, Austria, and Switzerland, British Isles. And you would see here that in terms of institutions and number of graduates, there's a clear focus on construction computing education in Germany. Or I would say Germany, Austria, and Switzerland, sorry. Followed really by the number of institutions that cover in the British Isles, but you would see that in terms of number of graduates, and I will explain that later, it's much lower. And it follows with Spain and Portugal, France, the Balkan area, Nordic countries. So you would see that pretty much there's a big gap between how many students are going through in Germany, and I think you notice that in the conference itself and the people that are here, and compared to the other ones. So in terms of that, there's a lot of concentration around local markets, but it is underserved in many eastern regions of Europe, which I think we can talk about it later. In terms of program type distribution, most of them are masters. So when you think about construction computing, it's a masters heavy model where digital skills are usually layered on top of programs that are basic in terms of either architecture, construction management, or civil engineering. And it helps a little bit too, because we consider that computing is a deep expertise into something that basically scales up somebody that already has a base of knowledge. But it's becoming less apparent where, and I will talk about it later on in terms of who offers bachelor's all the way to doctoral studies, but it's less apparent later on. In terms of, it's mostly full-time work, and presential dominance by itself is a skilling barrier. I haven't considered CPD because CPD is a lot more complicated to capture. There's a lot of fake CPD in the internet that is difficult to validate. So it's excluded from now from the analysis. But micro-credentials and stakeable qualifications likely need a larger role that is currently not available at the moment. If you look at content by region, you will see that there's one big winner here, which is BIM. And the rest, and I said there's about 40 topics, so you see the top 14, I think I put in this slide. There's BIM, and then there's the rest, okay? So we teach a lot of BIM in different manners and in different ways, but there's a lot more to computing than BIM, and we don't seem to do much more than that, which is a concern in itself. Obviously, BIM plays as the foundation for most of the other topics, and that's fine. But in terms of that, the shortfall is clear in terms of what do we do for information management, for example, or AI, or other computational topics. In terms of regional strength, for example, we have the Nordic sustainability and certain things like the British Isles focusing more on standards, Iberian institutions in infrastructure, or Italian institutions of BIM heritage. But it raises a question for future work, whether it's a strategic differentiation or really path dependence based on what the market actually requires. And again, lots of other topics that are completely uncovered. Interestingly enough, when we think about BIM, there's a lot of BIM delivery, I would say, in terms of getting our graduates to know about BIM, but not as much about BIM management, which is interesting. There's literally about only 27 institutions that cover BIM, when there's about 300 of them that cover, the other way around, 300 institutions that cover BIM, when only 27 of them actually cover what the management of BIM should be and what it looks like, which is a very concerning worry, I would say. Even in the top one, which we consider that would be the United Kingdom in the context, as you see, it's not even at 20%. So it could be also that we don't necessarily have data and it's delivered in a different way. But I would say most likely it's curriculum cycles around BIM that are not necessarily, and they're lagging behind the recent deliveries in terms of standards. What is actually travels together? So when we create programs, around any kind of topic, the things that go together usually is either digital twins with our AI or machine learning, and it's the strongest pairing actually, even though it's very, very niche. There's also a very interesting tooling cluster around BIM infrastructure and BIM software. There's also a little bit of co-correlation between collaborative workflows and ISO 9650, which makes sense. And surprisingly, the more natural, I would say more foundational civil engineering and architecture programs are, the more it anti-correlates with digital topics. So the more we consider a pure architectural program, the less digital skills are taught, which is quite concerning. In terms of pipelines, as I said, there's 53 institutions that offer the full ladder. So we go from bachelor's all the way to PhD, where they cover digital skills. But that's not the case for most of institutions. Most of them actually offer, as I said, master's only or master's and PhD. When we look at tuition costs, and that's probably one of the reasons why, for example, the British Isles, even though they have a lot of institutions that cover digital skills, they don't output as many graduates as, for example, the DACH region or Germany, Austria, and Switzerland. And the cost is really the biggest differentiator, where you would see that it's much higher in terms of threshold that you would see in areas like France, Germany, or Central Europe. And that is also something to see where you think that is actually scalable, because obviously you depend on parallel investment from other types of funding to cover and scale those numbers up, even though you're not charging as much for tuition. And the most important part, I would say, where we wanted to reach is the graduate capacity versus demand. I created 4 scenarios for the demand and for the supply of graduates to the workforce, basically considering that there's a very conservative approach where you have about 4% of the workforce needs to be digitalized in some kind of manner, to all the way 18%, oh, sorry, 6%, all the way to 18%, which will be what I call digital first. And if you see the line, that exactly is what we have at the moment. The estimated supply, because I consider that I have more or less about 75% of all the institutions and programs mapped at the moment. So I give myself a little bit of confidence, but not as much. And in terms of annual supply versus demand on the workforce in Europe, we are not making it even to the most conservative scenarios. So if we think about a future with AI and a future with more digital skills being needed and a labor shortage that is going to be increasingly need digital skills, we are not doing great. We are actually way, way underperforming, to the point we're actually lacking about 300,000 students per year when we actually supply about 25,000. So that makes sense. And we don't consider, for example, why some industry partners and the industry in general picks a lot of supply for their own workers from other sectors, like they pick computer science students, electrical engineering students, other types of engineers to do the work that they have, because we don't supply enough. This basically does the same, but we normalize by workforce by country. So that's why the UK doesn't show up, because I use Eurostat numbers. But as you see, even for the most conservative scenario, which shows, I'm almost done. For that, the Netherlands barely reaches, but all of across Europe, none of them actually show up to the point where we will reach that 6% in terms of graduate output. Basically, that tells the same story. We just don't have enough capacity at the moment to deliver what the industry requires. So in conclusion, there's a very concentrated but uneven distribution of graduate outputs in terms of skills and digital skills. There's a lot of supply that trails demand. We don't necessarily, even the best countries that we believe that are doing the best, and I can put the name is Germany, they don't do enough, and the Netherlands, they don't do enough. And I would say in terms of digital skills, I think we need a lot of work in terms of what demands in terms of competencies around digital skills, because this is not just as much about whether we can do something about it. This is more about a policy question. And well, it's complicated to meet actually the ambitions of the current situation and the workforce with the current situation that we have in universities. So sorry to be the down guy today. I'm done. Thank you.